Hi everyone, thanks for joining again. And here we are with our next speaker, Vasantharaju M.S. The topic is very interesting and a different one. How to choose AuthN and AuthZn strategy for a simple to complex service to service calls. About Vasant, he's a security engineer with AllBevis, a startup working on data privacy tools, and he's also was part of a software security. He was also working as a software security architect for multiple projects and programs building core security management product platforms. Now, what I'll do is I'll just give it over to him to take the stage and speak more about it. Over to
Yeah,
you, Vasant.
yeah. Thanks, Vandana. Thanks for the introduction. So I'll let me share my screen. I'll pull off my camera. Okay. Let me. mm, Entire screen allow. Yeah, yeah. Yeah. A little bit of introduction again, continuing. But yeah, I started my uh, cybersecurity career about 8 years back when I started working for McAfee. So it was very few roles related to software security by then. I got a chance to work as a software security engineer for some of the products with the McAfee. Yeah, so that's the introduction about myself. Yeah. And first of all, thanks to the OAS community for giving me this opportunity to present a talk in Developer Summit. And a big thanks to those who joined this session live. Yeah. Uh, yeah, to the topic, right? So, how to choose authentication and authorization strategy for a simple to complex service to service calls, right? So, these are the references. Kudos and credits to them. I want to I usually want to give the credit to them first before even starting the session. Yeah. And introduction. Um, let's look at the software architecture evolution and why service to service calls have emerged a lot and why the technical user has gained a lot of importance, right? So if you look at the software evolution, the software systems evolution, so which has gone through a lot of change in the last 30 to 40 years, right? Softwares were monolith and deployed as an on-prem solution when they came to existence. More and more software, for example, like payroll, logistics, or payment management, employee portal, started coming up, and then so a lot of software products gets deployed in on-prem, and then later there was a need for lot of communication between them, right? And when the internet boom happened and the advent of cloud service and distributed systems was coming up, right? The service to service communication has gained a huge share in the overall network traffic, and it also led us to the consideration of the technical user, right? Just think about the amount of traffic that is generated by the smartphones, like whether you have an Android or an iPhone, right? Just think about the amount of traffic that is generated by the smartphone, even it is idle or locked, right? So you don't make any user gesture in the phone to the phone, but the phone will still make a lot of traffic, right? It will generate a lot of traffic, and most of the traffics will be like on behalf requests and service generating the requests, right? So those are the typical service originated calls, right? So that's the importance. So that is the level of evolution for the service to service calls. It has gained a lot of importance and it has stayed relevant. In fact, it has a major share in the overall internet traffic, right? So that is why service to service calls has become a big consideration, and the technical user, I mean the user impersonation by the service, right? It has gained again gained a lot of importance, right? So what is out of scope for this topic? The SSO and the federated identity protocols and standards at depth. So be it SAML, OpenID, OAuth, right? I feel it's a little difficult to cover all of them within 30 minutes. I think I think even to cover the basics of the federated identity protocols or standards, I don't think it's possible it is possible within 30 minutes, right? But unfortunately, this forms the foundation of the authentication and authorization strategy. So what we will do is just compare these different standards and protocols for federated identity, and let's also identify where we can use what. So this is that way it will help us decide for the service to service communication, so what sort of authentication or authorization mechanism we can employ, right? So to start with, SAML, right? So SAML is actually open standard. It's also protocol and an open standard for authentication and authorization, right? So SAML opened up a reliable protocol for single sign-on. So SAML clearly defines set of rules, actions for each party involved in single sign-on, and also the message format used between the communication. So when the single sign-on was emerging, so SAML was one of the few um, protocol, and then later became the standard for the single sign-on, right? And the next one is the OAuth. So OAuth 2 is, so OAuth has two major versions like OAuth 1 and OAuth 2. So OAuth 2 is not compatible with OAuth 1 and will soon become, the OAuth 2 will soon become synonymous with OAuth. So which means like when somebody refers OAuth, they just mean OAuth 2, right? So OAuth 2 is standard for, it's again a protocol. It's still in a debate. There is a different school of thought whether OAuth can be considered as a protocol or not, but it is widely accepted as a protocol and open standard for authorization, right? That grants secure delegated access, right? So so OAuth 2 mainly focuses on the authorization. So it doesn't handle the authentication part. So that is when the OpenID pitched in. So they leveraged the OAuth capabilities, and then they introduced something called ID token, so which solved the missing piece, the authentication, right? So SAML mainly focuses on the identity, but we can also it can also take care of authorization. So SAML is complete. So complete in the sense like it can handle authentication and authorization completely. So a typical SAML where you would see is in the corporate applications. So if you work for an enterprise, corporate, or government agencies, right? That is where you will find a lot of SAML because SAML is widely accepted by the enterprise because it was one of the very few standards for single sign-on in the early stage, and then they continue to evolve and by adding features and then staying relevant, right? So if you to give an example, so let's say you are working on an employee, you're working as an employee for a huge corporate, right? And then you have a lot of systems like payroll, employee leave services, or employee portal, right? So you don't want to manage the username password for all of the different services, right? So you just single sign on in one place, and then the single sign on will create something called SAML assertion, so which will contain the user principal information and attributes, and also authorization scopes and some metadata, right? So this SAML this SAML assertion will be passed to each of the services, which will trust the SAML, and then it will rely on the SAML assertion for authentication and the authorization, right? Yeah, so that's SAML, right? And OAuth 2. So I will usually try to compare SAML and the OpenID because OAuth 2 cannot be compared to SAML and OpenID. Or SAML and OpenID both handles authentication and authorization completely, whereas OAuth is mostly focused on authorization, right? Um, but for the service-to-service calls, OAuth plays a huge role. So it is always relevant to take OAuth into consideration, right? Yeah. So OAuth is again, like I said, it's mostly focused on the authorization, right? And it is mostly relevant for the service-to-service calls, right? Whereas OpenID, uh, as mentioned, leverages the OAuth and in just includes the authentication part as well, right? Um, OpenID is more focused towards simplicity and deliver to market, right? Compared to completeness, which is the prime focus in SAML. So, which means there are few behaviors where SAML might have a better hand and OpenID might not. But all the consumer-based applications will prefer OpenID for its simplicity and then easy to adopt, right? So a simple example for OpenID, let's say you have a smartphone, right? Or there is a new web application that has come up, right? And it just accepts Google or Facebook um, sign in, right? So based on your Google or Facebook sign in, it can allow you to log into the site or the mobile application, right? So let's say you have an iPhone or an Android, right? You can download any of the apps, and those apps will rely on the Android sign in. If it in the case of Android, or in case of the iPhone, it will try to use the iPhone authentication mechanism, right? So those are the typical cases for the examples for OpenID. And when it comes to OAuth, the same mobile apps and the application we are talking about, right? Let's say we're talking about the apps, right? So the apps lets you sign in, right? Based on your Android sign in or the iPhone sign in. So that will be completely OpenID. That will be a typical OpenID communication protocol, right? Uh, but let's say you're not using the phone, and let's say you're locked in, right? And there could be a lot of on behalf requests, right? So those could be uh, our typical examples for OAuth, right? So and OAuth has different grant types, but let's see if we can go through that, because I'm not sure if we could cover that as well, right? Yeah. So with that background, so now we know what is SAML, what is OpenID, and what is OAuth, right? But the service calls authentication or on authorization mechanism need not limited by these three open standards or the protocols, right? We still have different other different options, which we'll discuss later. But these are the these lay the foundation at present to take a call, like what should be our authentication or authorization mechanism for the service-to-service calls, right? And yeah, so this is the interesting part. So if you look at a lot of architecture diagrams, right? So the browser is taken as granted for user, right? But in fact, it's not actually. So you have to consider browser as a service, right? The reason is the amount of Ajax calls it makes, right? So and these Ajax calls can also be cross-origin request, which means you open your favorite social networking site, right? And then you don't do any gesture, but this if you open the developer tools and look at the network tab, even without any user gesture, you will see a lot of requests that's been generated, right? So that is where you have to convince yourself, saying a browser is a service, and then we have to acknowledge the fact, and then we have to uh, we have to think browser also is a service, and then if there is any communication that is ajax or cross origin request, we should consider them as a typical service to service calls, right? Yeah, with that background, a little bit of um, knowledge sharing on the JWT JOT token, right? So JOT token, so JWT is basically Java, sorry, JSON Web Token. It is an open standard for transmitting information between two parties as JSON. They rely on digital signature, right? So you could verify the authenticity of the JWT, right? So it's basically, let's say we have two parties like party A and party B, right? Party A can sign the JSON, right? And then send it to the party B, right? And the party A will have the private key, which is used for signing the JSON, and the party B can verify if this is signed by party A using the public certificate, right? So public certificate, the public key. So it does gain a lot of traction with OAuth. So in fact, it's become synonymous with OAuth. So a lot of authorization service, right? They solely rely on the JWT token, right? So why JWT token for a web application, right? So now we have understood like browser is also a service, right? So if there are few cases, not for all the cases, but there are few cases where we could consider replacing the session ID with the JWT, right? So those cases are, for example, let's say you're developing a single page application, right? And then we don't want to maintain any session state in the server side, right? Something like stateless behavior. Then JWT is like proper approach to solve that case, which means like once the user keys in the username and password, right? And instead of creating a session ID and then mapping a session object, which will be maintained in the server side, we could just create the JWT token and pass it back to the browser in this case, right? And then browser, what it does is for every request to the server, it will attach the JWT token instead of this session ID, right? So the huge advantage of this authentication type is, so we don't have to maintain any user state or any session object on this server level server layer. So we can solely rely on JWT for user attributes or the other scopes or anything related to authorization. But there might be cases like where you still want to maintain session object. For example, let's say you want to track the last page the user visited. Obviously, for those cases, we still have to maintain object in the server side. But the user principal and the authorization part, right? Authorization and the metadata related to authorization. So that can be completely removed from the server layer. Yeah, so that's the huge advantage. And this is again, we have to be very careful when choosing JWT as an authentication mechanism, because for single page applications, the number of scopes are really limited, right? And when we say JWT as an authentication mechanism for the web application, so we are talking about sending the JWT token, JSON web JSON web token for every request to the server. So if we increase if the number of scopes increase, the payload also will increase, and that could be a performance consideration to take care. And it can work awesome for single page application, for not for multi-page applications. Like multi-page application is something where you want to maintain a lot of state, like for about the user behavior, like mentioned, like what was the previous page he has done, and if he has done any draft. So all those information has to be stored in the server side. So JWT is not the right case for the multi-page applications, right? So with that, let me move this. So let's look at service. Let's come back to our original discussion, the service to service call, right? The service is declined, right? So these are some of the considerations for these service to service calls. and but not limited to. But these factors can help us decide what should be our authentication and authorization mechanism in general, right? So first one is the network. Yeah, so the network could, whether the service to service calls happens over the internet, or is it local, or is it private or adjacent. So it depends a lot, uh, deciding the authentication and authorization mechanism. Payload size and the frequency. Payload size in the sense like what are we, what is the amount of data that's being transferred, right, between the service to service calls. And uh, to be honest, so it frequency plays a bigger role than the payload. So it's mostly the frequency and the payload together. We'll try to come up with to decide what kind of authentication and authorization mechanism that's needed for the service to service calls, right? And we also need to acknowledge the fact the payload size or the frequency is not something easy to estimate beforehand, but based on the benchmark whatever we have, we could calculate, like we could come up with the payload estimate and the frequency plays a huge role, right? And the fourth factor is the user involvement, whether any user gesture is part of the service to service calls, right? So a simple example for this, right? So let's say we are developing a print service, right? This print service um, trust the Google identity, for example, right? So you can use your Google Gmail account or Google identity, and then key in, and then you will be able to log into the printing service, this print service, right? And then the print service will ask for permission from you, saying, "Hey, I need to get the photos from your account from Google Photos," right? So you could, the user could choose to accept or deny, and based on that, the print service on behalf of the end user can talk to Google Photos and then retrieve the photos, right? So there's a user involvement in here, right? But whereas there could be different service to service calls, like for example, let's say we are trying to run a report on every day or something like a payroll report, right, for a specific I don't know, for a specific company. Or let's say we are we're trying to run a monthly report of employees activity or the leave status, right? Maybe. So those cases, it's purely this there is no user involvement, right? So it's similar to the cron job that we ran. So there is no user involvement there, right? Yeah. So these four factors are pretty important in deciding the authentication and authorization mechanism. And there are again there are special considerations which we'll talk about later. With that background, so let's take a couple of examples, right? So let's say the network is internet, which means the service to service call is happening over the internet, right? And the frequency is very high, right? And there is no user involvement, right? So the typical example, like I mentioned, so let's say we are calculating, I think I should come up with a pretty consumer based example, right? Let's say what's that example? Oh yeah, I think I couldn't come up with a consumer based example. So let's say we need to create a report or a monthly report, right? Or a daily report or some activity, right? So there is no involvement there, right? And in this case, we could go for OAuth client credentials flow, right? In which case, the remote service which we are calling will trust OAuth so authorization server, right? And they could create a client credentials and then share it offline to the service which is calling them. That's one of the most common thing, but um, that's that's also kind of fading these days. I'll talk about that. So let's take a very simple case, right? So where the service owner trust our authorization server, right? So they will create a client secret and then share it to the other service which is calling them offline, right? And the service which actually calls the service owner, right? Let's define service A is client always, and service B is the service owner always, right? So it makes our understanding simpler, right? So the service A will use client secret and the client ID and the secret to generate a client credentials token, right? And then using that token, they could make calls to the service B, right? So that's the typical OAuth client credentials flow. But again, if you want to do a deep dive, I really feel I think it's not possible to even cover one grand type of OAuth, right? So the second example, again the network, let's say it's the service call, right, is over the internet, and the frequency is again high, but there is a user involvement, right? It is very similar to the use case that we talked about, the printing service, right? So the printing service will ask for the permission from the end user, and the end user can accept or deny. And let's say they accepted. So based on that, accept. So the printing service can generate something called access grant, and using the access grant, it can retrieve the photos from the Google Photos. Right? So that is the access grant. So usually what access grant flow type is the most common type, most common actually the authorization mechanism, right? Um, in the third example, let's say the network is adjacent, right? Basically the other service, the service B that we are talking about, well, the service B that we are making a call is something like dedicated, right? Or the other example could be like where we do a sync up of the database, right? So the payload will be high and there is no user involvement, right? So in this case, we could use the client certificate to authenticate the user. And for cases like this, the authentic more than the authentication and authorization, the security, data security plays a huge role actually. So uh, which means the authentication still plays a role, but the data security, right, how the network security in this case plays a bigger role actually. So for cases like that, right, we could still use the client certificate, right? And these are some of the examples I came up with. And the conclusion is the authentication and authorization strategy for the service to service call, or basically the technical user, is still a case by case design. I don't think we could come up with a simple thumb rule saying like just follow this thumb rule to employ this authentication or authorization mechanism. It is still a case by case. But some of the parameters that we talked about will help largely to design the authentication and authorization mechanism for the service to service calls, right? And interestingly, it still continues to evolve a lot. So if you pay close attention to the public cloud vendors, right? You could have come up with something like just-in-time access, right? Where even though you're an admin, right? But let's say you want to work on some database object, a temporary credential will be created, and using that temporary credentials, a token will be created, right? And then this token will be, let's say, for an hour or two, and after that, it expires, and the temporary credential also is volatile, right? So just-in-time access, right, is becoming popular these days. So it works on the principle of very granular permission. Like, so let's say you have full access or admin access to a public vendor, right? Sorry, public cloud vendor, right? But let's say you want to operate in this some part of some service of the public vendor. So just-in-time access will give access to only specific services in the public cloud, right? So that's becoming pretty common these days, right? And cross account access. So this is also again, you if you work with the um, public cloud vendor, you could have heard this thought, right? So this is actually pretty interesting. So let's say let's go back to our example, service A and service B, right? And let's say there is a case where both the service rely on the basically trust the same authorization server, right? Usually, authorization server also as the identity provider, but need not be always. So let's say service A and service B, right? Both trust a single um, authorization server, right? In that case, what can happen is the service B will will have a policy saying I trust a service A account, right? And the service A can use their own credentials, like for example, client secret, but they could fetch a token that has a scope for service B. So the service B will need not have to create the client secret and then share it offline, right? So they will just say, see, we both are in the same, we both work on the same authorization server, right? So I will have a policy to trust only service A, for example, right? And the service A, all they need to do is they could use their own credentials, right? And then when they fetch a token, when they contact the authorization server for fetching the token, so they actually mention like I need a token for accessing service B, and then the token will have the scope related to service B. So this actually again has opened up a lot of interesting solutions for authorization, especially, right? Yeah, so that's what I actually planned for this session. And cheers. Yeah.
Thank you so much, Vasant, for the presentation. It was wonderful. I'm sure people will reach out to you with more questions. And it was great to have you at the conference. Thank you.
Yeah. Thanks, Vandana. Thanks, everyone.
Th- Thank you. And thanks to our sponsor for sponsoring the event. Um, Here we are. Thank you so much. And see you all in the next stream. Thank you.